Okay, thank you so much. So the recording is on, and then the those who are disturbing us kindly, please don't. You only put up the hand, and then we pick you to say or to give us the answer. So the first one who discussed the simple cell introduction, that was very good. Then another person. Yes, any other? Just like the first one, you can unmute and discuss with that what you learned or what to you a simple is. Yes. Yes, please.
So for me, I learned about a simple cell. And a simple cell is made up of two electrodes and an electrolyte. A more reactive metal becomes the cathode, while the less reactive metal becomes the anode. It commonly consists of a copper rod, which is a positive electrode, and the zinc rod, which is the negative electrode, and they actually dipped in the dilute sulfuric acid, which is the electrolyte. The electrodes are connected by pieces of conductive wires. That's what I learned about the simple cells.
Okay. Yes, thank you so much. Another one, any other one? We get some more, one person, so then we continue.
Hi, teacher.
Yes. Yes, please go ahead. Okay. Okay. So, what are the types of simple cells? Yes. And the simple cells we have. Yes.
Protons.
Uh-huh.
I know only protons.
Okay. So someone explained where what a simple cell is, what it entails, and then she explained the zinc plate and then the copper plate, and how maybe we need someone to take us through some more details of how electrons or negative ions transfer from one side of the zinc plate to the other side of the copper plate. Can someone explain that process? Yes. Are you able to hear me?
Pardon.
Okay, I'm saying, okay, I'm asking, can someone take us through how a simple cell work? The first one gave us a clear picture. We need some more detailed explanation, if any. Yes. Yes, Linda.
So for me, I think a simple cell gets its energy from the chemical reaction between zinc and sulfuric acid. And I think at the for the cathode, which is the zinc, I think it slowly dissolves and
Yes.
goes through the electrolyte, which is the sulfuric acid. Then for the anode, I think the electrons travel through the internal circuit and arrive at the copper electrode, where they are picked by the hydrogen ions from the acid to form the hydrogen gas. I think that's it. I don't know. And then we see the bubbles. Yes, I think I remember Tisha talking about that.
Okay. Thank you. So if there is nothing else, then I can ask some more theory questions and then we shall continue. What are the defects in a simple cell? Yes. What are the defects in a simple cell? Yes, Par.
There is polarization, which is the collection of hydrogen bubbles at the anode, which partially insulates it from the electrolyte. And then there's local action, which is the gradual wearing down of the zinc electrode or the cathode as a result of impurities on the plate. Yeah.
Okay. Thank you so much. Any other? Yes, we are looking at the defects in simple cell. And we know that there are basically two. That is the local action and the polarization. And she has explained the local action. She has explained the polarization. But I'm inquiring if there is any other person to throw more light on that. Yes, if there is is there anyone else? Please speed up because there is a lot to look at. Yes, I'm seeing a hand.
Okay, for me, I think it's not so different from hers, but I think for polarization, this is the formation of hydrogen bubbles on the copper plate. The hydrogen bubbles given off insulate the anode from the electrolyte. This, in other words, reduces the voltage of the cell. And then for the local action, I think this is, and then for local action, I think this is due to subreaction between the impurities in zinc and the acid, resulting into the formation of hydrogen bubbles again on the zinc plate. But then the hydrogen bubbles also insulate the zinc from the electrolyte. That's what I think. I don't know.
Okay. Yeah, it's not so much different from what Paul said. So any other? Okay. Another question is maybe perhaps the last one. Can someone take us through the ways through which we can minimize these effects, these defects?
Good afternoon, teacher.
Good afternoon.
For the polarization, how it is minimized, I think we use the polarizing agents like potassium dichromates or manganese 5 oxide, which oxidizes hydrogen to form water. And then also then also by brushing the copper plates occasionally. Then for the local action, how to minimize it, we rub clean, by rubbing clean zinc with matchlet, because it prevents impurities from reacting with the acid. And then also cleaning zinc plate with the concentrated sulfuric acid. And that is what I know about the minimizing of the two defects.
Okay, that's very beautiful. Thank you so much. Yes, Rodney.
For me, first of all, is by making sure that we use pure metals of zinc and copper for the electrodes, so that we can minimize the impurities and potential local action. And then we should also design we should also have proper cell designs that ensure proper insulation between the electrodes to prevent internal short circuits. We should also optimize the electrolyte composition, choosing a balanced electrolyte solution in a potassium hydroxide fuel cell to reduce the likelihood of concentration of polarization.
Okay, maybe to throw more light on someone who's asking where are we? We are in physics. And topic electricity, we are looking at for cells. And basically we are looking at how a simple cell is made. By the way, for your information, maybe we can remind ourselves of how who can remind us of maybe just a recap, simple recap. Someone is saying I'm completely lost. Who can us of the origin of electricity? That simple experiment which is connected to the generation of electricity using a flog, because that's where the concept of these cells came from, and then after it was modernized to the current that we now see. So, has someone ever come across some kind of generation of electricity flog? Yes,
Please,
Roddy.
shall I repeat the question? Please, shall I repeat the question?
Okay, I'm just making a recap. Someone who is saying that he or she is not picking anything, and I'm saying that we are building up on what your previous teacher taught last time. And when I asked, you told me that you were looking at cells, simple cells. We started on the defects. We started on how a simple cell works. Someone explained to us. Then we looked at the defects, that is the local action and polarization, and someone explained them to us. And then we were at a point of understanding how these defects are minimized. But now my question takes us a little bit back. My question is, the background of these cells. It connects with someone who discovered electricity, what that person first did. Something connects with a frog. Because if you understand that, then you know how to build it up with these simple cells. Why negative electrode, why positive electrode, why cathode, why anode. So if there is someone who has understood my question, you can say something and then we continue, because we have to also go into what we are supposed to have today. Those are the wet cells. Okay. Okay, let's first finish up this that we have been looking at, how to minimize the defects in, how to minimize, is the screen on? How to minimize defects in simple cells. We are still brainstorming. I haven't yet put on a screen the work that we are going to look at. Let us first brainstorm what we studied last time. Very fast. How do we minimize the defects in simple cells? Just one hand, one person. Rodin was saying something, then we shall get one more, and then we continue. Yes? Is someone saying something?
Teacher, I think they had already said them. Yeah.
Thank you so much. Okay, if there is nothing more, now we can look at the wet cells. And if you had looked at, maybe just before the wet cells, we have what we call the primary and the secondary cell. Who can give us the difference between the two?
Sure. I think the primary cells are the simple cells, and then when we talk of the secondary cells, there I think where they are the wet cells. Like I think the primary cells are the simple cells. Then for the secondary cells, over there are the accumulators. I don't know, teacher, I'm trying.
That is very good. Someone can build, someone can build on that.
Teacher, a primary cell is a cell that produces current as a result of an irreversible chemical reaction, i.e. when it gets it cannot be recharged when it runs down. And then a secondary cell is a cell that produces electric current as a result of reversible chemical reaction. That means it can be recharged when it has run down.
Oh yes, that is very good. And one more hand, and then we continue with what we are supposed to look at. Just one more hand. It is there.
Teacher? Sure. To me, I think the primary cells, if I'm to distinguish, like the primary cells consist of copper rod, positive, and electrons, and the zinc rod, negative electrode. Then when it is dipped into dilute sulfuric acid, and the electrodes are connected by the pieces of the conducting wires. That is how I know about the simple cells. Then for the secondary cells, because first we had passed through them. These are the cells that can be recharged and they produce electrical energy through the reversible chemical reactions that take place within the cells.
Oh, very beautiful. What does the word reversible mean? Yes?
I think reversible is like you can change something. You can reverse, yes, it's reversible, you can change it. Then irreversible, you can't change it.
Okay. So we have someone was asking, is there anything on the screen? And I said, let us first brainstorm. Now, I know that as we are going through this, it's not a matter of reading. We are supposed to just have a discussion. So these notes after the lesson, I'm going to share them so that we can get access to them for those who don't have them, and those who are asking for the details, we have the details. and then the explanation. So can someone read for us? Of course, this is a simple cell. As someone in the inbox requested for an explanation, you can read for us. Because
Teacher John?
Yes?
Sorry for interruption. I request, kindly requesting, since this was already a full lesson of its own, probably they could visit the YouTube channel, because in the previous lesson we ended on what? Let me see, the wet cell, and we're going straight to the secondary cell. So if we spend this whole lesson recapping, then us who have been attending will not benefit. So maybe if you could buy that idea.
Yes, very brilliant one. Okay, thank you so much. So I think we buy it. For those who missed, you go to the YouTube and check, and then we can continue with the lead acid accumulator. Someone defined the secondary cell in line with the lead acid accumulator, and then nickel cadmium alkaline or NiFo accumulator. So, but the basic thing to note here is that the secondary cells have capacity to be recharged, not so. So the reaction is reversible. Is it okay? So, all together?
Yes,
Yes.
we are.
Okay, so maybe just before we go into details of a lead acid accumulator, can someone share with us, perhaps you know how a lead acid accumulator has one kind of a secondary cell, how it operates? Just an explanation. Tell us, then we shall build on that.
Shall I repeat the question, please?
Can anyone explain to us how a lead acid accumulator as a kind of secondary cell works?
Let me try?
Yes.
So, according to what we talked about when we were in class, a lead acid storage battery consists of cells that are connected in series. Then each cell consists of a lead plate, which is negative electrode. Then lead 5 oxide positive electrode and dilute sulfuric acid as the electrolyte. So when the accumulator is fully charged and the relative density of the acid is about 1.25, and the how should I call it? EMF, that is how she gave it to us, of each pair is 2.2 V. So when the accumulator is working, both electrodes change to lead sulfate, and the acid becomes more dilute and its relative density decreases. That is how I know.
Yeah, that is very true. Thank you so much. Another one? Yes.
Okay, teacher, what I have is it's not so much different from hers. So a lead acid storage battery consists of cells connected in series. Each cell consists of a lead plate, which is a negative electrode, lead dioxide, and which is a positive electrode, and dilute sulfuric acid as an electrolyte. So when the accumulator is fully charged, the relative density of the acid is about 1.25, which she said, and the EMF of each pair is also 2.2 voltage. I don't know. Is it V? So the cathode is lead, the anode is lead dioxide, and the electrolyte is dilute sulfuric acid. When it is working, both electrodes gradually change to lead sulfate, where the acid becomes more dilute and its relative density decreases. That's what I think.
Okay. Okay. So anyone else? Okay, can someone read for us what we have on the screen?
So the lead acid accumulator, it consists of lead oxide as the positive electrode, lead as the negative electrode, and dilute sulfuric acid as the electrolyte. When the cell is working, both the plates, in brackets the electrodes, gradually change to lead sulfate, while the acid becomes more dilute and its density decreases. When the cell is fully charged, the relative density of the acid is about 1.25 and the EMF of the cell is 2.2 V, which is a voltage, I don't know. But when the cell is
2.2 V, yes, which is the voltage.
Okay. But when the cell is discharged, the relative density of the acid is about 1.15 and the EMF is less than 2.0 voltage.
Okay.
The relative density should not drop below 1.15 before the cell is recharged. The lead acid accumulators are more common than the NIF cell and are extensively used for ignition and lighting in motor cars. This is because they have very low internal resistance and hence can give a large current with very little drop in internal PD. I think that is it.
Okay. Okay, so can someone tell us something about the nickel alkaline accumulator or knife accumulator?
Teacher, about the nickel cadmium alkaline accumulate. The anode is the nickel hydroxide and the cathode is the cadmium with potassium hydroxide dissolved in water is the electrolyte. So the and then for the that is where I know maybe if we have also to talk about the nickel ion accumulator.
Yeah, nickel ion accumulator. Okay, thank you so much. Any other person? What can you say about the knife accumulator? Knife accumulator or another name is this, the nickel cadmium alkaline accumulator.
Okay, the anode for the nickel, which is the knife, I think they're the knife cells. Anode is nickel. Anode is nickel hydroxide and cathode is iron. In both cases, the electrolyte is potassium hydroxide, which dissolves in water. Yeah, I think that's what I know.
Okay, what is the major difference between the knife accumulator and the lead acid accumulator?
The difference between what and what?
Knife accumulator
the nickel
and
cadmium.
Yes, nickel cadmium alkaline accumulator and the lead acid accumulator. Or anyway, all of which advantage is one over the other.
Okay, I think the alkaline accumulators. I could give the alkaline accumulators and then the lead acid accumulators. Is it okay? Yes, because the nickel is under the alkaline cells. I don't know. So I think the alkaline ones require no special maintenance, while the other ones require special maintenance. And then for the alkaline, they may be left uncharged for a long time without being damaged. All the other ones, they get damaged if left uncharged for a long time. So the other alkaline accumulators, they are less heavy, and for the lead acid accumulators, they are heavy. For the alkaline accumulators, still they are long lasting, while the others are not long lasting. Still, for the alkaline accumulators, they provide large currents without being damaged, while the others, they provide low currents. So we still go to the alkaline accumulators. I think this is the last thing. They can withstand overcharging, while the others, they can be damaged when they are overcharged, I guess.
When they are?
This is that. When they are overcharged.
Okay, so can you pardon for the sake of someone who has not been following?
Okay, I'm going to again repeat. There are the alkaline accumulators. In the alkaline accumulators, we have the nickel, which they talked about. So the alkaline accumulators, they require no special maintenance, while for the lead acid accumulators, they require special maintenance. Two, the alkaline accumulators may be left uncharged for a long time without being damaged. So in short, they can be out of use for a long time. Well, for the lead acid accumulators, they get damaged if left uncharged for a long time. Are we together? So for the alkaline accumulators,
Yes.
they are less heavy, and for the lead acid accumulators, they are heavy. Still, for the alkaline accumulators, they are long lasting, while for the lead acid accumulators, they are not long lasting at all. We still go back to the alkaline accumulators. They provide large currents without being damaged, while for the lead acid accumulators, they provide low currents. Still, we go to the alkaline accumulators. These ones, they can withstand overcharging, while the others cannot withstand being overcharged. So in short, the alkaline accumulators are even switchable for supplying steady current for a long time. So I think that's what I know.
Okay. Any other person? Advantages of alkaline accumulators over lead acid accumulators? Yes? So we have some here. Alkaline accumulators have the following advantages over lead acid accumulators. One, they keep, she has mentioned many, so we have a few of part of what she has already mentioned. They last much longer, and also they keep their charges longer. Are there some disadvantages of alkaline accumulator over lead acid accumulators?
Yes.
What are they?
Okay. So I think for the disadvantages, I have a few. One, for the alkaline cells are expensive compared to the lead acid cells. And then for the alkaline cells, they have a low EMF and a higher internal resistance compared to the lead acid cells. And then they do not completely store a charge. Yeah.
Okay. By the way, we have mentioned a low resistance compared to the lead acid accumulator. Now, of the primary and secondary cell, which one has more internal resistance? when we compare now the primary and secondary cell. Yes? Any response? So the primary cells or the secondary cells are designed to have less internal resistance. And that's why they are suitably applied in like cars. They find applications where we need to generate more electricity, because compared to the primary cell, secondary cells have less internal resistance. Is that okay?
Primary cell.
Yes.
So, and someone saying that the disadvantages of, now we go back to disadvantages of alkaline accumulators over lead acid accumulators. Both alkaline accumulator and lead acid accumulators are under the what? Under the secondary cells, not so?
Yes.
Okay, and the disadvantages of alkaline accumulators, she mentioned them. We have a few here. We have very expensive compared to lead acid accumulators. Its EMF is only about 1.25 and tends to fall continuously on the discharge. So what was the EMF of the lead acid accumulator? Because this one goes up to 1.25. The one for the lead acid accumulator goes up to what?
2.2 volts.
2.2 volts. Very good. Is that okay?
Yes.
I'm hearing only four voices, but people are very
So
much.
the issue is usually when a teacher is teaching, there is an assistant. So people are used to raising their hands and then being asked to unmute. That kind of order. So this lesson is a different one as well. Because you're using a phone, so you cannot see people whose hands are raised. So they've been raising their hands, but mainly Linda and S.4 the ones have just been unmuting and then contributing.
Hey, so now I think I'm putting you in charge of reading for us the message in the chat. If there is anything, please read it. So you are in charge of reading what is in the chat. I cannot access it. So can we spend
so I request Mr. Bruno.
Yes,
please. Please move back to the Zoom app. And then you can give me maybe co-host rights.
Oh, okay. Who is that one?
Ruth.
Rodin, you also co-host. I thought you didn't tell me. Another one.
Okay. It's Ruth Namakula.
Me too.
Me too, who?
Okay, Rodney, your hand is up. Feel free to unmute.
All right. So I just had an inquiry regarding which cell has more internal resistance.
Regarding what?
Regarding on which type of cell has more internal resistance.
Mr. John, please unmute as well as Rodney.
Sorry, I thought I had unmute earlier. Okay, so my question was regarding on which cell has more electrical resistance between the secondary and primary cells. And I was reading through some text and it was telling me that secondary cells have more internal resistance than primary cells because they have a more complex structure compared to primary cells. Although the internal resistance is quite low depending on how this cell is going to be used, on what kind of electrical output is needed from the cell. But on a general basis, secondary cells tend to have a higher internal resistance than primary cells due to their complex structure and the fact that they are rechargeable. So I wanted someone to help me iron that out and probably put me on the right track.
Teacher Bruno, don't forget to unmute. First, go back and unmute, please. And we can see your screen. Teacher Bruno, please move back to the Zoom app and unmute so that we can be able to hear you.
Sorry. So, yeah, we are responding to Rodney's question when I said that compared to simple cells, secondary cells are designed to have a relatively lower internal resistance, and he has explained it, whereas primary cells, in most cases, not in most cases, relatively have a higher internal resistance. So before I go into depth of what I was trying to mean, can someone say something? Yes, any response? We are comparing internal resistance of secondary cell vis-a-vis internal resistance of primary cell. Okay, are you able to hear me? Oh, I'm still muted.
We are able to hear you, though there is no feedback from any participant as well.
Okay, fine. I think I can throw more light on it. So let me just give maybe a simple example. For example, if we have a very small car, a very small car that consumes 100 liters of petrol. No, okay, let's simply say 10 liters of petrol daily. 10 liters of petrol daily, a small car like my car. Altogether. So, but again, we consider a very big car like Sinotruck. A very big car like Sinotruck, it consumes 15 liters of petrol daily. Now, when you compare a small car like a Mica consuming 10, Sinotruck consumes 15, given the task that Sinotruck has to do compared to the tasks that this simple Mica has to do, how do you conclude which one consumes more relative to the other?
Of course, the Sinotruck, I think, consumes more.
Now, given the complexity of the Sinotruck and the task that is supposed to do, the 15, you would expect it to consume over 50 liters. You get my point?
Teacher John.
Yes?
There is someone in the chat who's lost. Patience is asking you to first repeat for her that scenario. She's requesting you to repeat the scenario.
Okay. Yes, we are comparing internal resistance of primary cell and secondary cell. And at one point I said, these primary cells have high internal resistance. And when compared relatively to secondary cells have a lower internal resistance. But Rodin mentioned something which was correct, that when you compare them generally, of course, the secondary cells, because of complexity, they will have a bigger internal resistance. But the point in which I explained it is this. I want you to pay attention. That if you have a very small car, like Ipsum, and this Ipsum consumes 10 liters of petrol, let's assume that Ipsum and a big car, they both use petrol. Of course, we shall not go into details that one use diesel, another use petrol. Let's assume that they both use petrol. So I have a very small car, and that is Ipsum. Ipsum consumes 10 liters of petrol every day. And then there is this big car, like a bus. And then let's assume this bus uses petrol. So it consumes 15 liters every day, a bus. Now, given the complexity and the task that a bus is supposed to do compared to an Ipsum, if you compare relatively, you notice that ideally this Ipsum wouldn't have consumed that 10. To find that the difference between Ipsum and a bus is just 5 liters. So the conclusion would be that this Ipsum consumes a lot of petrol, and also that the bus, given the task that is supposed to do and its complexity in design, if it consumes 15 liters, just a difference of 5 from this Ipsum, the conclusion can be that it consumes little. Do you get my point?
For me, I've not yet got it. I don't know, because even there are some who are entering late. And Joanne is also saying she has not got the point. But Technospark as well as most of them are saying they have not got it. Okay, it's 50-50. Some have, some have not.
Okay, can I have someone who has gotten it to tell us what he or she has understood?
Linda?
So, teacher, this is what you've actually said. There is a small car and a big car. The small car may be consuming something like, let's say, 5 liters. I'm assuming, and then the big car is consuming something like 10 liters. But then on the complexity and the way it does its work, it should be consuming actually more, because the difference is really so small. You get it? So that's what I've actually got, that in short, you conclude that this big car is actually consuming less because of the difference. Yes, and this small one is consuming more because it is doing something small, yet the difference there is actually also small. So would actually wish if it was consuming something like 1 or 2, but if it's 5 and the other is 10, then the difference is really small, meaning the small one is consuming more and the other one is consuming less, depending on what it's doing.
Yes, so given what the simple cell, the primary cell does, its output of voltage, its internal resistance is high compared to what we would expect it to be. And then when compared with a secondary cell, the internal resistance is lower in regard to the tasks that or the voltage that it's supposed to produce. So I want us to compare this with what Rodin was trying to do. Yes?
I'm requesting for the definition. It's Ruth. I'm requesting for the definition of internal resistance. Let me see. I don't think we got it.
Okay, can someone define for us what internal resistance is? Internal resistance. The opposition to the flow of current inside a cell, not so?
Yes, teacher, I've got it.
The opposition to the flow of current inside the what? Inside the cell.
The cell.
So now I want Rodin to re-explain, then we try to connect with this example that I've just given, because it's Rodin who needed some more clarification.
That Rodney went off.
He went off?
Yes, seems his network.
Oh, sorry. Okay, but I don't know whether people have gotten something that we are trying to mean.
And send that feedback in the chat if you have understood.
Any feedback?
Let's say is yes. She's agreeing. She has gotten something. Then any other person? Linda. Forget 5. We're good to go. Rachel.
Okay. Okay.
And
let us
Shiba.
go to let us go to how an accumulator is being charged. I think we know that an accumulator is simply a battery. You have all seen a car battery. So the word accumulator isn't something very abstract, just like a car battery. Only that the difference is that some use lead acid, then others use nickel alkaline. So can we try to see how it is charged? It is very simple. We just connect one terminal to the what? We just connect one terminal to the DC source, another terminal, we just connect the terminals to the DC source, one side to the positive, another side to the negative, and then the rheostat to adjust the current that is flowing. So the side that is connected relative to the positive terminal gains more positive charges, and then the other one, of course, when there is gain in positive charges, or when there is loss in negative charges. Let me repeat this. When there is loss in negative charges, what happens? Deficiency of negative charge means means what?
It means more positive.
Very good. So when we have more of negative charges, it means on the other hand, there is less. So where there is less of negative charge, that is positive charge. Where there is more of negative charge, that is negative charge. So we connect to the which anode carries a positive charge? Cathode or which electrode carries a positive charge? Cathode or anode?
Linda.
Yes?
I think it's the cathode, which carries a negative charge, and the anodes a positive charge.
Very good. Okay.
Teacher, but most people in the chat are saying anode. I think this needs clarification.
I'm welcoming answers. Then after we harmonize. Any other?
From the chat, there are no hands raised as yet, but from the chat, Joel is saying anode, Shiba is saying anode, Nicole anode, Trevor anode, someone using their latitude is saying anode.
Anode for what?
As
for
well as
positive,
Joan
negative?
for negative, but Bridget says cathode.
For negative.
So that is what is coming in.
Okay. So anode is supposed to be positive. It is cathode that is negative. That okay?
Yes, teacher, it's okay.
So anode is that positive side of a cell, and then cathode is that negative side of the what? Of the cell. So why I'm asking that is that we have, for instance, our battery, which is this one. So if we say that anode is that positive side, which side is this now? This one, and then the cathode is this, not so?
Yes.
So in design, the anode is connected relative to the positive terminal of the DC supply, and the cathode is connected negative to the negative terminal of the DC supply. So can we have someone to read for us very fast?
It's only Linda whose hand is up. Okay. The hands that have gone up now. Ruth Colette. Let me see the hands that. Okay. Ruth Colette, unmute.
The positive terminal of the accumulator is connected to the positive terminal of the battery charge so that current is passed through it in the reverse direction. In series with the accumulator should be a rheostat to regulate current. The leads of the cells should be removed. Then the battery charger, which is in series with the accumulator, is switched on and left until the EMF of the cell rises to 2.2 voltage.
Okay. So what do you pick from this? Yes.
Edith, do you want to contribute? Your hand is up. Or you forgot it up by mistake.
So we have, okay, let me try to say something here. This is our DC supply. So now this is our accumulator, of which originally we don't know which side. We know that this is the anode, and the other side is the cathode. But they carry no charge. I mean they carry no, they are not yet charged. So what happens is that as electrons travel in this circuit, so more electron will be coming to this side of the cathode, and then they'll be leaving through the anode. All together. So as more electrons are coming to this side, we shall have a pile-up of electrons, and then as they are leaving, we shall have deficiency of electrons this side because they are leaving. So as more electrons come to this side, and we have electrons coming to this side of the cell, it will make this one negative, and where electrons are leaving this side, making deficiency of electrons, leaves this one a positively charged. You get that?
Pardon. In that movement of, is it movement? Okay, yes, let me call it movement, but the movement of current, already it was a positive. So does it make it a positive, or it leaves it as a positive for the part of the anode? Or maybe also the part of the cathode as well?
No, originally, there is no charge. We are just showing that it becomes positively after, but originally there is no charge. But we simply know that this side is anode and this is cathode, because that we know the electrodes. So it is the flow of this electron that makes this side a negative as electrons enter into this side, and as electrons leave, they create a deficiency at this point, making it a positive terminal or a positive electrode. So these charges you see come after electrons are passing through the circuit.
Okay.
Get that?
Yes, I've got it.
Okay. Now, yes, that we have something that I wanted us to go through before. At what time are we supposed to end?
Supposed to end at exactly 4
Hey,
p.m.
we still have time. Okay. There is I wanted us to first have that background, and then we can go through these activities. And you told me that you already looked at the primary cells. We don't have to go back to that. Identifying primary and secondary cells. Okay, maybe you can just go through this activity 1.4. Study, read for us, study figure 1.4 and identify the cells that can be recharged. Cells that can be recharged, those are called secondary cells, and those that cannot be recharged are called primary cells. Can someone take us through? Which are the secondary and which are the primary cells?
Okay.
Yes?
You raise your hand so that we can carry on the discussion. Linda, your hand went up first. Please unmute.
So I think that in A and B, I think those can be recharged, and they are the primary cells. And then for the D and
Okay,
C,
Linda. There is. Sorry, I had to do that. Someone else wants to contribute. Charity.
I think A and B are the secondary. Wait,
Okay, Charity, let's give you space. I'm going to ask you to unmute after 1 minute. Let's hear from Camps.
I think A and B, I think are primary cells, then C and D are secondary cells.
With the
And
reasons?
me as well. Okay. Camps, unmute and accompany your answer and reasons. Camps?
Yes. According to my opinion, A and B, I think they are not charged, whereas C and D are charged.
Whereas C and D are charged.
Then Kathy?
I think A and B are
So
primary cells.
A and B are primary cells and D?
C and D are secondary cells.
Okay. So let us go through part B. Briefly describe the differences between the primary and secondary cells. Can we have someone to take us through this? Differences between the primary and secondary cells.
But I only have one. It is
It's okay.
Primary cells are the disadvantages, yeah? Let me begin with the disadvantages. Under the primary cells are not recharged in case they are used up according to their power.
Okay, another one. Thank you so much. Another one. Differences between primary and secondary cells.
Linda?
So, teacher, you actually talked about this as we were talking about the cells. So, I think for the primary cells, you said that they can't be recharged once it stops working, and then for the secondary cells, they can be recharged when they stop working. And then the current in the primary cell, the current is produced as a result of the irreversible chemical change, as someone had defined. And then for the secondary cell, the current is produced as a result of a reversible chemical change. And then the primary cell has a lower EMF, and the secondary cell has a higher EMF. And then we are having the primary cell works for...
Linda, you're going to give the answers of okay, from the chat. Linda, I request you type the other answer in the chat so that the rest also get an opportunity to contribute. So from that chat, Belki, I'm going to give Shiba's answer, though I think it's the other way around. Primary cells can be recharged, while secondary cannot be recharged once they are used. But according to Cabs, that answer is she has turned it the other way around. I hope I'm right. right. Then Belki says a primary cell is potable and its electrolyte is in jelly form and can't easily pour. Then Dosha has not put out the whereas for a secondary cell. Treasure Tyra says secondary cells keep their charges longer, while primary cells do not keep their charges longer. Okay. Lastly, Linda, do you have any other answer different from that?
Yes. The last answer is the primary cell works for a shorter time and then the secondary cell works for a longer time. I think we talked about the internal resistance, right? Yeah, the primary has a higher internal resistance, and as teacher you had explained, and then the secondary cell has a lower internal resistance. Yeah.
And now maybe we can say, instead of higher, we can simply say high. You get it, yeah?
Yes.
The primary cell has a high internal resistance. Secondary cell has a low. Because when you say higher, it's like it's higher than the other one.
Okay.
But it is high compared to its soft. Is it okay?
Yes, teacher.
Thank you so much.
Welcome.
I think we can go to another question. Advantages and disadvantages of each of the cell. You have discussed that in the differences. Okay. These you can write them somewhere. You can write these questions. Write them. They will guide you as you are reading. Detailed research on cells and answer the following questions. What are the common practical applications of electric cells? List some of the recent advances in cell technology. I'm going to ask a question on Roman 2. Something has come into my mind. Okay, let us brainstorm, because I wanted to leave it as an assignment, but people might be having some responses to give. Key question: how can we use cells in our day-to-day life? Part A. Someone can we have a guide to take us through the questions as we are picking on people to give us response?
Mackenzie.
Okay. Do a detailed research on cells and answer the following questions. What are the common practical applications of electric cells?
People, let's go through. There is a lot that we are supposed to cover after this.
Rosette. Rosette, please unmute.
Should I read the questions?
No, you're answering. You're answering that question. Had you prepared to do so?
Oh, okay. Not yet.
Okay.
Someone to give us an answer.
Linda.
Okay, teacher. For me, I'll only give like 2 because the other people also have to give anyway. I think first they are used in battery-driven vehicles, as we see the secondary cells, and then I think they're also used in emergency lighting.
Explain.
Like in torches, I think in torches, because we also see the cells there, and then also I think I don't know, and in phones also.
Okay. Yes, another. Thank you so much. Another one.
Any other answer? You can as well type in the chat. Let me see. Okay, Charlene says they're used in cars, e.g. in drone taxis. Then if I've asked you to unmute, you first introduce yourself because you're using a gadget name. Someone using Dell Latitude, please unmute and contribute as well.
Are they over? Roman 2?
Yes, they are.
What are some of the recent advances in cell technology?
Okay, Linda.
Yes.
Linda. Vanessa says some primary cells can now be recharged.
Yes. Is that true?
Yes, that only. I'm not sure.
I think it is true. Some primary cells, they have now created some cells that literally can be. They are not batteries, they are simply primary cells that can be charged because we have seen rechargeable battery torches. Haven't you seen those
Then,
such?
yes, Jeff, I have. Then who? Douglas is saying what of the inbuilt batteries? He's not sure of the answer. And then Alice is saying charging using solar. Linda, you also have an answer?
New advances
Okay.
in cell technology, someone has mentioned. The other said inbuilt batteries. Yes, inbuilt batteries. Yes, because by the time these secondary primary cells were introduced, then we didn't have these computers, but now we can have inbuilt batteries inside computers. So someone is saying solar cells. Yes, now we have solar cells. The cells that are used to generate electricity using solar panel. That is very true.
Okay, teacher. Okay, teacher. Mine is not. I don't think. Okay, I watched a documentary whereby they were talking about the stem cells, and then they are used for treatment. But I don't know whether it's actually correct or they actually know about it.
Stem cells that are used for
Yes.
treatment of what?
I don't know in hospitals. I don't know because I haven't made some big research about it.
Okay, I've heard of stem cells, but I don't think they are cells that we are talking about in physics. Maybe I shall also have to do further research, but I think stem cells are so much in biology. Is it okay? So we should look at them. We should look at them in that angle, not in generation of this physics electricity. They might be in position of generating some kind of energy, but that energy is in line with the life related things like animals. but I don't think
Okay.
they are so much in production of this voltage in physics we are talking about. But I know they are stem cells.
Okay.
Mm. Mm-hmm.
Tabs is saying dynamo cells.
Yes.
If that is what is coming in through that chat.
Okay, thank you so much. Somewhere, stem cells are special cells produced by bone marrows. You see, like I said, they are related to like the human flesh, produced by bone marrows, in brackets, spongy tissues found in the center of some bones that can turn into different types of blood cells. Okay. So another part, find out applications for which cells are not appropriate. Yes, Roman 3, let's brainstorm that very fast. Applications for which cells are not appropriate.
Alice says cooking.
Mm-hmm. Cooking. Uh-huh. Yes, I think that is true. Another one.
When Cab says when welding in a workshop.
Yes.
So that's what's coming in. So first stop the screen share so that we do not see what's going on. Yeah, from the chat, from Patience is saying washing and ironing. Bridget is saying washing. Okay.
Interruption. Yes, please. Sorry for that. So we are continuing with the highlight other sources of. Okay, Roman 3, take us through very fast.
In the chat, hook left when you had a Cab say welding in workshop. Then Priya says washing and ironing. Bridget also says washing. Nora says, what about trimming hair?
Trimming hair. If you are using a scissor, but if you are using a machine, there are some machines that have rechargeable cells. And so some machines use electricity direct, but there are some machines that use rechargeable cells, those that are recharged. Is it okay? Are we there? Okay. Highlight other sources of EMF apart from the simple cell. Let us look at this one and we got something else. Are you able to hear me, friends?
Yes, teacher.
I thought you couldn't. Okay, let's go back. Take us through Roman 4, then we continue. Highlight other sources of EMF.
Charlene. Charlene says crystal pickups and then solar cells.
The first one is it?
Crystal pickups, like a car, a pickup. I don't know. That's the spelling here. Pick then ups. UPS. Maybe she can raise her hand and throw more light on that. Charlene?
Charlene, please.
Please explain your point. Charlene, please unmute. Maybe she can type that. But Charlene, we're waiting for you to unmute to explain that point. Then Ruth says electric generators, Ruth Colette. Then Ali says solar panels. Colette still says transformers.
Transformers? Yeah. How?
Yes, that's what you know.
Let us first brainstorm on transformers. Transformers, are they sources of EMF or they simply regulate EMF? They simply either step down or up. Are they source of EMF?
Colette, please unmute.
The rest, what do you think about transformers?
Linda?
Teacher, according to my research, they're actually telling us even transformers are also sources of EMF. And then I also have something like thermoelectric devices and then photodiodes, something like that.
Photodiodes, yes.
Yes. Yeah, that's all I have.
Okay, photodiodes, that's okay. But still on transformers, can someone throw more light? Because what we know about transformers is they can increase or reduce on electricity. But as a source of EMF, if someone can throw more light for the rest, it would be good.
Yeah, I think they are source because they work on the principle of electromagnetic induction, where a varying magnetic field around a coil induces an EMF in a secondary coil. So I think it is part of it.
Yeah, that explanation is true. Can you repeat for them?
Sorry?
I mentioned earlier on that a transformer works on the principle of electromagnetic induction, where a varying...
Can you first tell us electromagnetic induction means what? Electromagnetic induction, generating or inducing. Induction is inducing electromagnetic, inducing current from magnetism.
Yes, thank you.
And so, and inducing current is the same as inducing voltage, because where there is current, automatically there is what? There is voltage. So electromagnetic induction, induction of electricity in the process of magnetism. Okay.
Should I go
Continue.
ahead? Where a varying magnetic field around a coil induces an EMF.
Induces an EMF. Okay.
In a secondary coil.
In a secondary coil. That is true. I think men have not yet looked at that area, but for those who are doing further research, we can also guide that you look at what you call mutual induction. Mutual. You try to research about the word mutual induction. Is that okay?
Yes, teacher.
Okay, but if you have not yet covered that part of magnetism, it is okay, don't worry. Here we are just pointing out transformer as a source of EMF. I got so much interest for all others to know how EMF is produced from a transformer, and her explanation is true. Any other?
Yes, Habs highlights still on the transformer, and he says especially Van der Graaf transformers. And then Bridget says electric generators, solar cells. Charlene still adds in what she's calling crystal pickups, that they are piezoelectric effect crystal pickups. Then someone using Dell Latitude says Bluetooth devices. Then Isaac says inductors, batteries, and generators from someone using Infinix. Then yes, that's what's coming in from that chat. There are some hands up. Rose Jolie, please unmute.
I think bicycle dynamos also. That's my answer.
Thank you. Over to you, teacher. That was the feedback.
Okay. So, can someone read for us that? Yes.
Ndagano Queen Esther.
Okay. Did you know chemical cells convert chemical energy to electrical energy? A cell is an electrical component that provides voltage and current. Cells are very useful in portable devices, for example, in torches and radios. Primary cells have very high internal resistance as compared to secondary cells. For this reason, secondary cells provide a larger current compared to the primary cells, hence can be used in areas where large currents are required, for example, in starting an engine of a car.
You understand that? Remember, we discussed the concept of internal resistance of primary cell vis-a-vis secondary cell. Okay. Identifying other sources of electric. This work is in Longhorn Book 4. Longhorn Book 4, it is there. So what are other sources of electric current? Yes? Other sources of electric current, we have them here, or electricity. So which sources are these?
Okay, because of time, we're going to have one person. One person contributes Cheng. Okay, Cheng muted. Let me just read from the chat. Treasure says C is our windmills. Solar panels from Shiba, I think that's A. And then B is hydroelectricity from Belki. And lastly, D is a generator.
Okay. So, okay. So that's all what we can have about cells. I wanted us to, before this lesson ends, I wanted us to introduce ourselves to current electricity. I don't know if it is okay with you.
Yes, teacher, it's okay. Just an introduction so that people get the real picture of it.
Okay. So current electricity, can someone, not even someone, maybe I can, let me go to a whiteboard. If there is anything in the chat, kindly read for me. Someone who is okay. So if I have a battery like that, I connect it to a certain load. Load can be anything that you connect to a battery. It can be an electric appliance or anything that of course uses current. So the flow of electrons, when you connect a battery, the negative terminal produces electrons, not so? And these electrons drift from the negative terminal to the positive what? To the positive terminal. Is that okay?
Yes.
So the drifting of electrons, excuse me, the drifting of electrons from negative to positive, automatically that creates current. Current to flow from the positive terminal to the negative what? To the negative terminal. Is that okay? At least we have some background how current is generated by a simple cell, by a secondary cell, and we have seen that current can also be generated in other ways using windmills, generators, using solar panels. We have also seen hydro electricity source, that is water. So the flow of electrons in a circuit allows current to flow in the opposite direction. Okay, now let us go back and read this. Yes, Maria.
So could have wanted to read.
She wants to read, yeah?
I think so.
Let's put it there. You can read.
Maria? Now you can read.
Measuring current. Current is measured using an ammeter The ammeter is connected in series with cells and other devices which may be used. This ensures all the current flowing in the circuit has to go through the ammeter, where it is measured in units called amperes.
So current is measured using an ammeter. An ammeter is connected in series with cells and other devices which may be used. This ensures all the current flowing in the current has to go through the ammeter. Maybe this one we can connect it, but as an introduction, let me emphasize something very important here. If we can, I think is okay. Let me just take it to the whiteboard. So when we are connecting current, when we are connecting a battery, an ammeter, and then maybe the load, and then go back to that. This is positive. This is negative. So the current flows like that. So something that I want us to note is that the ammeter is connected in series with a battery. Why? Because it has to measure all the current that flows from the battery. And where do you think a voltmeter is connected? A voltmeter is connected across the load. Across the what? The load. Sometimes the load is represented by R because it is the load that has some resistance, R. Is that okay? So this, I wanted us to know that whereas an ammeter is connected in series with a battery to measure all the current that is flowing, on the other hand, a voltmeter is connected across the load, so that to measure the PD across this very load. Load can be represented by R for resistor. Or sometimes, instead of putting it this side, they can even put it inside. Can even put it inside like that. Or even simply, we can also have it like that. Yes, Linda. Sing a hand. Okay, ask a question because we are about to end.
Linda?
So, sure, you've talked about the PD. You've talked about the PD. The PD. What is a PD?
Oh, okay. So PD is simply the voltage. We shall go into details of these ones, or the teacher will go into details, but PD is simply the voltage. PD stands for potential difference, but in simple terms, it is the voltage across a certain load or across the load. So there is the voltage of the source, but there can be also the voltage across the load. These two voltages might be different because of some factors. Whereas, okay. we are saying that the ammeter, it is a device or it is an instrument that is used to measure current. Because it is used to measure current, it is connected in series with a battery so as to measure current that comes from the battery. Now, on the other hand, the potential difference of voltage across the load, if this is my load, and then I want to know the potential difference across this load. Potential difference is simply the voltage. When we are talking about voltage, we don't say voltage that pass through, no. We say voltage across. So the word across is in line with the word across doesn't necessarily mean that it goes through, but simply means we are measuring its value between 2 points, say for example, point A and point B. But we shall have more details on this. So this is just an introduction. We shall have more details on this. Potential difference, PD simply means potential difference. The word potential means voltage. Potential difference means difference in voltage. But we shall have more light on that. So for now, I want us to stop here unless if there is a burning question. But I'm going to send some work to Mr. Kaziba. I think he will forward it to you or to your groups. I'm sending some work to Mr. Kaziba. Then these questions, you'll try them out. Okay, so next time you begin on current, electricity, and then you go through more of what it entails.
Okay, thank you so much, Teacher John. I hope I got the name right. Thank you for you all who have participated. Credit goes to Linda and Safra, who has kept the lesson active for a while. Okay, let's have a closing prayer from one of us so that we end the meeting. I'm going to choose at random for this one. Let me see. Enid?
Okay, let's humble ourselves and pray. Heavenly Father, we thank you for this wonderful lesson that you've enabled us to have today. Lord, we thank you for what we've learned, Father. We thank you for sending your Holy Spirit to be with us, and we thank you that we've understood some parts, Father Lord. Father Lord in heaven, we pray that you protect our teacher, Father, you protect us all, Father Lord. May we go back, research more about this topic so we can get to understand it by the time we go back at school, Father Lord. I pray that you fill us all with your Holy Spirit, Father. May you not take away your Holy Spirit from us, Father. May we grow in you, Father Lord in heaven. Pray all this believing and trusting in your Son Jesus Christ. Amen.
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 Thank you so much. Any other question?